All right. Thing like we just started. Some things I want you to look at in the book, some additional resources and momentum. We need to talk about or remember all the things that you do with rational expressions. You have some great examples of factoring here and some videos in the additional resources, but the one I want to mention is the one that we did not do in college algebra, that number 22, factor x to the 6 minus 27 x cubed. Now, remind me this. Can somebody just real quickly make up a problem for me that's the difference of two squares? What's your favorite difference of two squares on the planet? That would work, but give me something with an x in it.
3x squared minus 20 is x squared. 28 y squared.
I gotta have perfect squares though. 3 is not a perfect square. Give me a number, your favorite number that's a perfect square. 9. So if I had x squared minus 9, that would be a difference of two squares. X squared is a perfect square, 9 is a perfect square. They're subtracted. Just remind me real quickly what it looks like when I factor x squared minus 9.
X plus 3x.
Yeah, I knew that'd come back to you. X plus 3x minus 3. So the difference of two squares, both terms have to be a perfect square and they're subtracted. That's one that you should already know already. But this number 22 is not the difference of two squares because 27 is not a perfect square. And y cubed is not a perfect square. I do notice, however, that 27 is a perfect cube, and that gives me a good clue as to what this binomial is. It's the difference of two cubes. We can factor the difference of two cubes or the sum of two cubes, and the handout that I gave you with the words turned sideways, these are the words that I use to factor the sum or difference of two cubes. The first one's the sum of two cubes, second's the difference of two cubes. When I recognize, hey, I've got the difference of two cubes here, the mental image I immediately have is, that's where I get a binomial times a trinomial. I put a little parentheses and a big parentheses. So this number 22, that's for my binomial, that's for my trinomial. And then I just start talking myself through this process. The binomial, I take the cube root of the first term. What's the cube root of x to the 6? What could you multiply times itself 3 times that would give you x to the 6? Yes. Because x squared times x squared times x squared would give me x to the 6. So I took the cube root of the first term, then I take the same sign. If this is a minus, then in my binomial, I'm also going to have a minus. If the original problem had a plus, my binomial factor would also have a plus. So looking at these words down here, this is my cheat sheet until I get it in my head. Cube root of the first term, same sign, cube root of the last term. What's the cube root of 27y cubed? When you multiply times itself 3 times, that would give you 27y cubed.
It's not 3y.
It is 3y. Why did you think it wasn't?
Oh, I thought that's what she just said.
I just didn't hear you. I didn't hear you. My hearing's going. My vision's going.
She said that and you're like, no. I was like, what?
I don't know what I was responding no to, but I didn't even hear you say anything. I'm sorry. My children are starting to have to yell at me. I'm growing old. So my binomial factor is x minus 3y. The next words say, look at that binomial factor and square the first term. What would you get if you squared that first term? Yell at me. X to the 4th. The next words say, take the opposite sign. That means if my binomial factor has a minus in it, the next sign in my trinomial is going to be a plus. Then multiply both terms. I'm looking at my binomial. I need to multiply x squared times 3y. What would that give me? 3x squared y. The next words say that last sign is always positive. And then I square my last term. I'm looking at this binomial, and square the last term would give me what? Make sure you're multiplying 3y times 3y is 9y squared. 9y squared. Don't just square the y, square the whole term. So you may have to do 3 or 4 of these to have these words in your head, but these words are foolproof. If you go, do what these words say, then factoring a sum or difference of 2 cubes is not difficult. You have to recognize it. I recognize it pretty quickly. Both of those are perfect cubes. And then you have to refer to this until you have those words in your head. All right. So that's all the factoring we have time to do. Let's talk about rational expressions. These are 2 of the biggest things you need to be good at in calculus. So adding, simplifying, multiplying, and dividing fractions. We don't have time to do examples of that, and there are fine examples in the book. I don't see the example of simplify that I was looking for, but I see the example of multiply and divide as example 3 on page 34. To multiply fractions, you just factor everything and then cancel your common factors. You can cancel any factor in the numerator with a common factor in the denominator. Once you've canceled all you can cancel, what you're left with is your answer. And then how have you known since the 4th grade how to divide fractions? What do you do when you have a fraction division problem? Multiply by the reciprocal of the second fraction. So this B part, you just flip the second one, and then it's just like the A part. You factor everything to a factor, and you cancel your common factors.
Just flip the second one?
Yes. Yeah. The exact same thing you would do if in elementary school I gave you 3/4 divided by 2/3. You would multiply 3/4 times 3/2. Same thing in algebra, it's just ugly with x's in it. Yep. Anything, there's a great example in the book, we're not going to use class time to do. But the harder thing, what makes adding and subtracting fractions harder than multiplying and dividing fractions? You have to have a common denominator to add and subtract. You don't have to have a common denominator to multiply and divide. So adding and subtracting is harder, and it's something we have to be good at in calculus. So the flip side of the handout I gave you, just as an example to walk us through adding and subtracting rational expressions. That's the back of the page I just gave you, and did you have that one as well? Okay. If you're adding and subtracting fractions process has more than 4 steps, then you're making it harder than it is. I've written out to the side, let me say that these first 3 things, I'm going to call that step A. Those next 3 things that I have in the brace, that's going to be my step B. And those last 2 things is my step C. Those steps, A, B, and C, each of them has some subparts, but that'll walk me through adding and subtracting any rational expressions in the world. So here's my step A. Here's the original problem. Step A, right here, says factor any denominator that will factor. I'll look at my original denominators. The only one that would factor is that x squared plus 5x. I can factor out an x. So I factored the only denominator that would factor. I leave a blank after each term because in basic math, if I was adding 2/3 plus 3/4, I'd have to find the common denominator and then I'd have to multiply each one by whatever it took to make it have the common denominator. That's why I left these blanks. Multiply by whatever you need to make it have the common denominator. So factor the denominators that will factor, leave a blank after each term. If one of the fractions is subtracted, distribute the negative through the numerator. This original problem had -2/x. If I leave that minus out front, I may forget to distribute it later. So in this step A, I changed it to plus -2x to help me remember to distribute that negative completely. Any questions about step A? Factor any denominator that will factor, leave a blank after each term. If any fraction is subtracted, put that negative in the numerator so that you remember to distribute it later. Step B, find the LCD. I have to have something that x plus 5, x, and x times x plus 5 will all go into. In basic math, if we had denominators that didn't share a common factor, we just multiply them. That common denominator is 12. Well, this x and this x plus 5 don't have a common factor, so you just multiply. The LCD is x times x plus 5. That's what all three of those would go into. What if this had been an x plus 5 squared? Well, it would have to be down here. Also have to have an x plus 5 squared because you have to have the highest exponent of each factor. So number 4 is find the LCD. Write it down for every term. I had 3 original terms, so here's my 3 new denominators. Step 5 is the hardest to put in words, but it basically says, look at this first denominator and tell me what you have to multiply this fraction by to make it have this denominator. What's it lacking? It needs the x, so I'm going to go back in and put an x over x in the first blanks for step A. What do I have to multiply the second fraction by to make it have that LCD? It needs the x plus 5. I'm going to go back to step A and put x plus 5 over x plus 5 in that second blank. What does the third fraction have to be multiplied by to make it have the common denominator? It already does, but since I can't erase a blank that I typed, I'm just going to put a 1/1 in it. If I had written it in pencil, I would just erase it, but since it's typed, I just put a 1/1 there. That's step 5, figuring out what to put in those blanks.
All you have to do is multiply across the top.
And that's step 6. Well, not quite, but that's number 6. Multiply to get your new numerators. And make sure that when you multiply 4x plus 1 times x, you distribute that x completely. Make sure you multiply it by both terms in this numerator. What will this new numerator become?
4x squared plus x.
Exactly, 4x squared plus x. When you distribute -2 through x plus 5, what does the second numerator become? -2x minus 10. And right here is where you can see if I had left this minus out in front of the second fraction, I might accidentally have -2x plus 10 here. I may have forgotten to distribute that negative. Putting it in the numerator is what helps me remember to distribute it completely. And what's this third fraction numerator going to be? It's still just 10. That's step 6, multiply to get your new numerators. Step 7, add the numerators and keep the same denominator, just like we do in basic math. So when I combine like terms in those numerators, what is the resulting numerator going to be? I don't have any other square terms. 4x squared, then what?
Or minus x.
1x minus 2x is negative x, and then what? Nothing, because negative 10 plus 10 is 0. So here's my sum, and I would be ready to say that's my answer, except for sometimes when you add two fractions, what do you have to do before you have your final answer? You have to reduce it, and you reduce it by factoring and seeing if you have any common factors. That numerator, you could factor out an x. It would leave you a 4x minus 1. So you do have a common factor of x that you can cancel. And your answer is 4x minus 1 over x plus 5. Just like the difference of sum and difference of two squares handout, I have words on there, and you have to get those words in your head. What's the only way to get those words in your head? Practice. Do a bunch of sum and difference of two cubes with that beside you, and eventually those words will get in your head. These words have to get in your head. If I'm telling you that factoring and working with rational expressions are two of the most important algebraic skills in calculus, then I expect you to take it very seriously and say, I'm going to master those two things. Because I know if I don't, I won't be okay in calculus. Because this is so important, I have one more typed. It's darn close to the one that I've typed on the handout. Let's just do it. Let's do it right here. Here's what we're going to do. I'm going to work it at the same time as you. You're going to work it by yourself. You're going to refer to the words at the top of the page. And after we get step A done, everybody's going to look up and see if their step A looks the same. So just do step A and look up. Here's what your step A should look like. The only thing you may have different than me, you may have written this first denominator as x plus 3 squared. That's okay. I did remember to put my negative in the numerator of the second fraction so I wouldn't forget to distribute it in the next step. Everybody give me a thumbs up if you're okay in step A.
How did you get the x plus 3 times x plus 3?
Factor that. X squared is x times x. 9 is 3 times 3. If I multiply those together, I get the middle term. So if you have trouble with factoring, you got a bunch of videos to watch tonight. Got it? Is that okay?
Yeah.
Okay. You need me to wait a minute? You're still working on step A? Okay. All right, look at step B, you work it, and then look up after you get step B done. And just in case anybody's having trouble with step 5, find the LCD, or step 4, find the LCD. Let's go ahead and agree what's the LCD for those 3 fractions. Got to have an x plus 3, another x plus 3, or you could write x plus 3 squared, and an x minus 3. So that's the LCD. Continue. What you should have after step 5. Multiply each fraction by whatever it needs to make it have the LCD. Look up just a minute, let me ask you something. What's different about the kind of multiplication you have to do here and the kind of multiplication you have to do here? What word pops in your head when you see a binomial times a binomial? Fold. On first, outer, inner, last. Make sure you fold that and put it here.
Your last one, did we have to add an x plus 3 as well, so it can also have an
I was checking it and I would have found that in just a second. You're absolutely right. The last one needed not only an x minus 3, but it needed an x plus 3 as well. The other x plus 3.
wasn't sure how.
No, you're absolutely right. And I was looking back at it, but you found it before I did. What you have?
No, because I wasn't sure how to do it.
Okay.
I was multiplying them together first.
This one's a little bit uglier than the one I did as an example.
So why did that need the x plus 3 as well?
Because the LCD had 2 x plus 3s, and this only had 1. So I had to give it the other. And then the x minus 3. It's whatever this lacks in making it become this.
Okay.
to get that last numerator, I fold the x plus 3 times x minus 3, and then I distributed the 7. All right, that's super ugly. Let me combine like terms now. We didn't get quite as far as I would have liked to have gotten, but do the best we can. Stop at 47 in the homework. 1 through 47 odd. Watch some factoring videos if you need to. Watch some rational expression videos if you need to. Come see me if you need to. Or my daughter is back from Brazil, yay! And she's in the tutor center to help you if you need some help in pre-cal. She's there 9 to 3, Monday through Thursday. She's the little bitty cute one. Yes, sir.
I will have the book Thursday most
All right.
likely. So for the homework that's for Wednesday, will that be printed out as well?
It's in Momentum.
Oh, okay. I only saw 1 and 1.3.